Hello, greetings, and welcome to our lecture. My name is Miracle Chibuzzor Marcel, and I'm the founder and the director of the Pan-African Citizen Science E-Laboratory. So today we are going to be learning about thunderstorms and lightning, part 1. There are going to be other parts to these lectures. It might even be up to part 3, okay, because it's going to be very long. So for today we are going to be talking about thunderstorm and lightning. So, as a gentle reminder that this lecture is sponsored by the Free AstroScience group. So at the end of these lessons, learners should be able to define what a thunderstorm is and explain how water from the ground become thunderstorm. Because the thunderstorm that we see today is from water. It is from water. Okay, then learners should be able to identify where thunderstorms happen mostly on Earth, the places it happens, and describe what a lightning is. And finally, learners should be able to explain how storm clouds become electrically charged. So this is what I have for you for part 1. So what is a thunderstorm? What is a thunderstorm? A thunderstorm is a powerful weather system that forms when warm and moist air rises rapidly into the atmosphere, creating a giant storm called a cumulonimbus cloud. I said a thunderstorm is a powerful weather system that forms when warm and moist air rises rapidly into the atmosphere, creating a giant storm called a cumulonimbus cloud. So I hope you can pronounce that. A cumulonimbus cloud. Cumulonimbus cloud. So I'm going to show you what that all means. So for a storm to be classified as a thunderstorm, it has to have these ingredients. It has to have lightning, it has to have thunder, and it often comes with heavy rain, strong wind, and sometimes hail. So those are the ingredients that forms a thunderstorm. Now, how do we understand a thunderstorm? When we see a thunderstorm, how do you understand? How do you understand and say, okay, this is a thunderstorm? So So to understand it, we need to know how water from the ground become a thunderstorm. So starting from the sun, this is the sun. We had eyeglasses. You can see how happy it is. So the sun is the source of most of the things happening on Earth. So uh, it takes Earth 24 hours to rotate, to spin about its axis, and the spin brings about day and night. So we have 12 days. We have 12 hours in a day, and we have 12 hours for night. Okay, for any location. Although sometimes there are some changes, sometimes we have longer days and shorter night, but on the average we have 12 hours in the day and 12 hours in the night. So during the day, sunlight, the heat from the sun, it heats up ocean water body, and it heats up rivers. It heats up lakes. These are some of the examples I'm just showing you on the slide. This is rivers. This is example of oceans, and so this is wet soil. Okay, it heats up wet soil. It heats up the heat from the sun is incident on plant leaves. Okay, you can see that there. Okay, we also have water on the road, maybe after rainfall or maybe road construction or whatever that brought the water there, maybe flooding. Okay, so the sunlight from the sun heats up these surfaces, it heats up rooftops, it heats up land areas, or even the clothes you spread outside, or maybe you want to dry your want to sun dry your food or your fish, meat or whatever, you know, so it heats up all of these surfaces, okay, and gives it energy. It gives you the kind of energy called the kinetic energy. Kinetic energy is the energy of motion. So when it hits up this water, so on the molecular level, they acquire kinetic energy and they want to escape. Okay, they want to escape. So this is just um, the diagram that summarizes everything I've just said here. So whether from the sea or from the clothes you spread outside or from the rivers. So once the heat is from the sun, is incident on these surfaces, it gives them energy, kinetic energy. So they become they become they become steam or what we call water vapor. So we have a term for that. We call it evaporation. So evaporation is the conversion of water, or sorry, any liquid, any liquid from the liquid state to the gaseous state. Okay, so for here we're going to use water because we're talking about water here. So that's it. Now now depending on the temperature of the day, the warmer the day, the more this evaporation happens. I mean, this conversion takes place. So that is why during the day when the temperature is high, maybe you're in the desert area or where the sunlight is so high, evaporation is very rapid in those regions. So you experience more evaporation. So now this water vapor or steam is being carried by warm air. And I'm going to explain that. I'm going to explain that. Now, I want you to recall, if you have been in the physics class, about heat capacity, the concept of heat capacity. Heat capacity is a concept that, that tells us how much heat a substance can contain. Okay? How much heat a substance can contain. So you can imagine water and cooking oil. So imagine water and cooking oil, and you have equal volume of water in your cooking oil. I want to know which one has more capacity to retain heat. So when you boil them, you discover from experience, because we all cook. So when you boil them, you discover that the oil would boil first, okay, followed by the water, okay. The reason is because oil at the same conditions, okay, the same conditions, the oil has lesser heat capacity than water. Okay, that is the idea of heat capacity. So when it comes to this arrangement, when you have a land and sea, where you have land and sea, okay, so you discover that the land has the land has lesser heat capacity than the sea. You can even think about that. During the daytime, if you come out without wearing any shoes or slippers, the ground feels so hot. Okay, it's because it has less heat capacity. But if you go to any swimming pool or any water body, and if you touch it, you feel like it still feels cool. In fact, sometimes they still feel cold a little bit. Is because the water has higher heat capacity. So now there is air everywhere. Okay, so now the air in contact with the ground in the daytime get heated up. They get heated up faster compared to the air floating above the water, because they are not, they are in contact, but there is no air, there's no heat being reflected. But here, the heat capacity, because of the low heat capacity, the heat is being reflected. So once they are reflected, the heat warms up the air molecules above the ground. So what happens is that they expand. They expand. Remember, um, from density equation, when the volume increases, the density decreases. When the volume increases are inversely proportional to each other, the density decreases while the mass remains the same. Okay, so now now once the the density increases and uh, the density decreases, the the air is going to rise. Less density is going to what? Rise. Just a natural setting. It's going to rise. And when it rises to the upper atmosphere, where it is no longer in contact with the ground, it's going to lose some of the heat into the universe and cools down. When it cools down, it comes back. Now, once this air is going up, once this air is going up, the air here, no, the warm air here are going up, the cooler air here are going to move in to replace them. So as this air go up, they cool, their density increases, okay, like their volume decreases, their density increases again, and they return. So that is a kind of a cycle there. So I'm just doing some recap of convection currents in physics, okay. So this process reverses during the nighttime, but that is not part of what we are going to be discussing today. But I just want you to, take this day convection, the land and sea breeze convection into consideration because it's going to help what we're going to be discussing today. So now, as these warm air are rising, okay, they are rising because of less dense. They are they are taking with them these water vapor or steam. So that is what I mean by the water vapor is carried by the warm air that I said before. Okay, they take with them these water vapor, and that process is called the updraft. So the process of taking up this moisture with them is called the updraft. Now, when they get to the atmosphere, the cloud, the moisture will condense and become cloud. Okay, so and this is because up in the atmosphere the pressure is less. Okay, and once the pressure is less, the warm air will begin to be cold, and they are going to be unable to retain the heat, the heat on the steam. So what happens is that there are particles in the atmosphere, dust particles in the atmosphere. They're gonna they're gonna be they're gonna be like act like a surface through which this water vapor we condense into liquid water again, and sometimes they can even form ice crystals. So this is the process here. So here you have the particles in the atmosphere. Here is the rising water vapor plus the heat, the warm air. So here are the particles acting as surfaces for the condensation of this steam, and when they come together, they become bigger in size. They form clouds. That is how clouds are formed. And this kind of cloud, just normal cloud, we call them the cumulus clouds. So here are the cumulus clouds, just normal cloud that we see in the daytime during fair weather, and we have different kinds of them. We have different kinds of cumulus clouds. So no, we are not discussing clouds now. So I'm just explaining how clouds came about. Maybe next time I'm gonna delve deeper into clouds. Now, how about these gigantic clouds? How about gigantic clouds? How are they formed? And if you look here, you can see this aeroplane. No, that's the level of aeroplane flight. So what happens to this gigantic cloud called the cumulonimbus cloud? Now, I told you that the air is rising. Okay, when they rise to this extent, they can condense and become ice crystals and become water again. But depending on the quantity of the vapor, some of them can keep rising upwards. They can keep rising upwards, and as they continue rising, the clouds grows upwards. So that is why the clouds continue to grow upwards. So that is what makes it different from here. So it depends on the quantity of the vapor. If the vapor is less during dry seasons, they're gonna have this kind of things. But if the vapor is much more, they're gonna form huge clouds. and these are the ones that cause rainfall, heavy rainfalls. So we call this kind of cloud the cumulonimbus cloud. Why these ones are just called the cumulus cloud. So know the difference. Know the difference. Now, right inside this huge, gigantic crowd, things are going on. Okay, we have sections where the warm air keep rising. So warm air will keep rising. You can see the arrows there. Warm air will keep rising, and the cold air from the atmosphere we we sink. Okay, so air is rising, you know, rising with the warm, like with the steam, or water vapor, while the cold ones they have given up their water, the water particles they carry with them, and they're rushing down. Okay, they're rushing down. The convection current is still going on there. Okay, and so without rushing down, during rainfall, that strong wind that you feel during rainfall is from there. Okay, it is from there. So you have this warm air going up, you have these cold air sinking down, then you have, so you do that process, the water droplets, that I just showed you here, the water droplets are going to collide and grow bigger. And as they become bigger and bigger and they become more dense than the air, the rain is going to start falling. So that is why we have rainfall and we have winds. The winds that is blowing is coming from the sinking cold air. That is why we feel fresh air during rainfall. Then you're going to see lightning and thunder. Lightning and thunder, and that constitute a thunderstorm. Okay, now I have not explained lightning and thunder how they come about, but this is the process of of how a thunderstorm is born. So you can see it there as an example, a thunderstorm. So I've defined what a thunderstorm is, and I've also explained the process or the formation of a thunderstorm. Now, where do thunderstorms happen mostly on Earth? Okay, um, thunderstorms happen everywhere. Okay, they happen everywhere, but their degree differs. Okay, their differs. If you want to know where it happens often on Earth, that place has to be hot and it has to be a wet region. And places like that on Earth are places like Central Africa, you have South America, and Southeast Asia. So now, I have compiled five places, five highest places that experience the highest thunderstorms. Okay, just the top five. There are many, and they fall within Central Africa and Central America. And we use a term called flash rate density, which is flashes per kilometer squared per year. Okay, to describe just the flash, the frequency of thunderstorms. Okay, so number one place that experiences the highest thunderstorm is at Lake Maracaibo in Venezuela. Lake Maracaibo. I don't know if I'm getting the pronunciation very fine, but it is in Venezuela. Okay, the flash rate density is 232.52. So that is the highest in the world, followed by a place called the Kabare in the Democratic Republic of Congo in Africa. It experiences a flash rate density of 205.31. Then we have another place in the same Democratic Republic of Congo called the Campene with a flash rate density of 176.71. Then we have another place in Colombia called the Caceres. I don't know if I get the pronunciation well. Okay, with a flash rate density of 172.29. And number fifth is Sake. at the Democratic Republic of Congo, which is having a flash rate density of 143.21. So if you summarize this, you can see that the thunderstorms are experienced in Venezuela, and Congo, and Colombia. The top five occupy the top five positions. So now, how about cloud mass? Does the cloud have a mass? Have you ever thought about having a mass? I probably must have heard that they are quite heavy. So if they are heavy, yes, I believe they are very, very heavy. I've heard that too. If they are heavy, why are they not falling down and causing havoc? Like an heavy object falling down and causing havoc. Why are they not, falling down and causing havoc? For instance, the cumulus, the cumulus, where the cumulus cloud, which is cloud for fair weather, is having a mass of about 500,000 kilograms. Or you can simply, you can imagine it as 100 elephants, because one elephant is about 5,000 kilograms. So if you divide that, that will give you about 100 elephants. So imagine 100 elephants. Just one of these clouds is just 100 elephants. So why is it not collapsing and causing havoc? Imagine an asteroid of that mass collapsing on Earth. That is going to be the end of this planet. That would be the end of life on this planet. So, but why are we not experiencing that? How about this gigantic thunderstorm cloud called the cumulonimbus cloud, which is about 1 billion kilograms, which is about 200,000 elephants. So why are they not falling down? And the reason is because of they are less dense than water. They are massive, but then they are well spread out. So from the equation of density, their density are usually equal to or less than the density of air. In the same way you have water. There are some objects that float on water. Okay, and the reason why they float on water is because they are less dense than water. Those that sink down are more dense than water, so that's why they sink down like stones and irons. Okay, but if you want those stones and irons to 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 float, they have to be spread out. So that is exactly what is happening with this cloud. So for the cumulus cloud, the density is just 0.5 uh, gram per cubic meters, and the density of air is just 1 gram per. I think it is 1 gram. Yeah, 1 gram per cubic meter, but it's less than that. So the cumulus cloud is less than that. Then how about, so this one does not cause rain, it doesn't cause, if you can even go outside and see it up there in your sky, it doesn't cause rain. But how about these thunderstorms? It is between 1 to 3 gram per cubic meter, and these are the ones that cause ground because they are they are almost equal or above to the density of air. So that is why they cause heavy rainfall. So anytime you have this kind of cloud or in your sky, just know that rain is about to fall. Now, as a summary of these thunderstorms, I said the thunderstorm must have lightning, it must have thunder, and it must come with heavy rain, strong wind, and sometimes hail. So you see, there is a difference between a thunderstorm and a thunder. A thunderstorm is a system that contains lightning, thunder, and which often comes with heavy rain, strong winds, and sometimes hail. So now, let me now delve to lightning, to the science of lightning, what causes lightning, and later on I'm going to explain thunder, maybe in another part. So, lightning. What is a lightning? Lightning is simply electricity in the sky. Electricity in the sky. You know, normal electricity that we see go through wires, okay? Go through power lines, through batteries, through guided systems, okay? But for lightnings are just electricity in the sky, okay? So electricity flowing through air, the clouds, and sometimes the ground. So those are lightning. So now to understand lightning, and I'm going to recap the concept of electricity from physics. Okay, I'm going to just do some little revision on the meaning of electricity from physics perspective. Now, everything in the universe contains electric charges. Everything in the universe con- contains electric charges, and we have discovered that there are two main types of these charges. We have the plus, which is the positive charge, and we have the negative charge, which is the minus. Now, both charges have what we call the electric field lines. Okay, so for the positive charge, the electric field lines are pointed outwards. So you can see the arrows pointing outwards, and for the negative charges, the arrows are pointing inwards. Now, what happens when you bring them together? When you bring a positive charge and a negative charge together, they are going to attract. So we say all like charges attract. So you can see from the picture that the field lines will move from the positive charges to the negative charges. Now, when you bring the same charges together, they are going to repel, whether positive positive or negative negative. They are going to repel. So we say like charges repel. I hope you are following what I'm describing here. Now, normally, if you bring all the positive charges and all the negative charges in the universe, they're going to cancel each other. They're going to pair up perfectly. Remember, I didn't say if you bring all the charges on Earth, because Earth, in this perspective, and this perspective is not an isolated system because Earth is being bombarded by solar wind, cosmic rays, so charges are being poured on Earth through we talked about that. Uh, we talked about that doing solar wind and aurora. Okay, if you want, I would suggest you go listen to that. So Earth, in this regard, is not an isolated system. So it is. If you bring all the charges on Earth together, they're not going to cancel that because we have we have a net charge. It could be a net negative charge or net positive charge. I don't know. Okay, but we have extra. One is above one another, and these charges are being created by physical agents like friction, especially friction, induction, heat. Okay, so these agents are the ones that counterbalance them. So that is why on Earth we don't have equal amount of charges. Okay, we don't have equal amount of charges. Okay, but now imagine you have two objects. Let's just break two objects, two isolated objects here and this one, and we give this one negative, should be positive charges, and give this one equal amount of negative charges. So what is going to happen when they are close enough? When they are close enough, nothing is going to happen. Okay, but energy is there. There is electric field. Remember the electric field I told you about. The electric field is going to move from the positive to the negative. These flashes are not the electric field, please. Okay, electric field is going to move from, because electric field are imaginary fields. Okay, they're going to move from the positive to the negative, but no flashes. But at the time when the potential increases, the air between them is going to break down. No, the air is acting as an insulator. We call it a dielectric medium. Okay, because of the increasing potential, it is going to break down. And when the air breaks down, the charges from the negative or from the positive, either of them, will jump. And when they jump, they they combine, charges begin to flow, they combine, and sparks will begin to erupt. So that is why if we bring two wires together, they're not touching, okay? They're not touching. If you bring them together, it is very dangerous to put two live wires or positive and negative. It is very dangerous. Don't try it, okay? But if you keep them even at this length, there's going to be sparks. That is going to happen. So, but don't try this at home, okay? I'm just trying to explain something. So now let me bring this idea to how storm clouds become charged. Now, remember, right inside the cloud, a thunderstorm cloud, some amazing things are happening. Like I told you that uh, the cloud is filled with water droplets, ice crystals, hailstones, and some strong rising and sinking fields. Remember what I explained in my last lecture. These particles are colliding violently, okay, aided by the strong rising and sinking air. Remember, so these particles are what colliding, and because of the movement of the air is separating them into positive and negative regions. So at the top of the cloud, you have positive charged particles, positive charges, and at the bottom you have negative, negatively charged uh, ions, charged particles or water molecules. So now you have created these fields. So there's electric field existing here, electric field existing here. Now even the ground, because of what we call electrostatic induction, okay, and as induced, sort of attracted the positive charge in atomic level in particles on the ground. So the ground is going to become positively charged, while the negative charge are going to be pushed down. But I'm focusing on the positive charge. So you have electric field existing between this place and this place, and that becomes dangerous because electricity will flow, becomes very dangerous at this point. So you have these thunderstorms. You have this thunderstorm I've explained before. Now, at this point, if you walk without your slippers or your shoes, you're going to be hit by electric thunder. I don't know if you have experienced that. Yeah, You know, maybe I'll explain. I'll talk about that in my next lecture. One of my next lecture to explain this so that you don't you don't to walk barefooted during rainfall, because as you're walking, you're acting as a charged point, and they like charge point because through you these charges are going to enter through your body because you become a sharp end, and this thunder strike can locate you and harm you badly. So that is why buildings have thunder protection. Those high-rise buildings have thunder protection to be able to control these thunderstorms. So when the electric difference becomes too strong, like I have explained here, the air cannot hold it anymore. So the charges suddenly connect. So the charges begin to connect. This one will connect. This one will connect. This one will connect. So electricity rushes through the air at nearly the speed of light. So that flash that we see becomes lightning, and the heated air produces thunder. I'm going to come back to thunder, about how heated air produces thunder. Now I've explained so this is how lightning happens. So I've explained thunderstorms, I've explained lightning, I've not explained thunder. Okay? So maybe I will do that in my next lecture. But observe here. Observe that this lightning is happening internally in the cloud. Those kinds correspond to these ones, those ones that happen within. The positive at the top are reacting with the negative charges below the cloud here, and also internally here too. You can also have it internally here too. Now, these ones that reaches out that we see, that touches the ground, is this one. Okay, so that will bring me to the end of my lecture. So if you have any question, you can post it in the comment section. So in my next lecture, in part 2, I'm going to be explaining thunder and other concepts. Thank you very much for paying attention.